closely related to the idea of a stored procedure is that of a trigger. So a stored procedure allows us to put any arbitrary functionality we like into a function that's actually maintained by the database and can be invoked from any application that has appropriate permissions. A trigger is a way of telling the database to execute one of those stored procedures under certain conditions. As in many cases with a relational database, there's a ton of infrastructure that allows you to maintain relational integrity, to ensure that there's certain constraints that are being followed, and to, in general, allow the database to sort of backstop your applications or your console-oriented queries in such a way as to maintain data integrity. And you can kind of see the combination of triggers and stored procedures as kind of the ultimate in that expression or that ability that gives you a ton of flexibility to determine how to ensure the integrity of your data. So by way of introduction, why do we care about stored procedures? Well, again, to maintain data integrity that's not supported by other means. Obviously, something like making sure that a primary key is unique across a table, or that a foreign key refers to a valid primary key in the referenced table is part and parcel of what the database can do for us. And because it's built into the database, it's going to be very efficient, very fast, highly optimized. But there's going to be other things that we want to be able to do to ensure integrity or to do other kinds of functions on demand that aren't covered by the database. And this gives us a very general purpose way to address that. It's important to keep in mind that triggers actually are going to be executing code automatically after you do something in the database that could potentially make a change to the database. So notice that the list of functions here does not include select. If we're reading information out of the database, there's no possible chance that we're going to make any changes to the database that could cause problems or could cause referential integrity issues or that kind of stuff. So these triggers really only apply to those data manipulation statements that could actually make a change. So insert, update, delete are the key things that we have encountered regularly. There's also a function called truncate that basically throws away all the data in a table. So it's normally something that you just don't want to avoid for the most part. And we're not going to really talk about that in a lot of detail, but you can consult the documentation for Postgres if you want to learn about more how to use that. So insert, update, and delete will be our principal focus here. Some characteristics of triggers. One thing we can do is have a trigger that's invoked before the database operation. And by the database operation, I mean the operation that your application or that you're requesting in a console window or something like that. That's the operation of interest. I'm going to insert something into the database, or I'm going to update something in the database. So the idea here is that a trigger can be triggered before that operation takes place or after that operation takes place. If we trigger the trigger before the operation, we can actually have the trigger basically skip that operation. So if we're trying to update data in such a way that our stored procedure says, yeah, that's probably not the right thing to do, we can cancel the operation. We can also change the data that's being, say, updated or inserted into the database. If we want to make a modification to a particular field that's part of an insert or an update statement, the stored procedure can actually access the data that we're trying to modify in the database and perhaps make changes to it. The process here, it's a two-step thing. We've seen already how we create new functions in the database with the create function data manipulation. I've got those backwards. Data definition statement. But that's not sufficient to actually trigger its execution. We, of course, can trigger it manually when we use it inside of a query ourselves. But if we want it to be triggered automatically, which is kind of the point of a trigger, we have to use the create trigger statement as well. So the create function defines the function that's going to be executed. Once that's in the database, stored persistently, we can then do a create trigger, which will tell the database under what circumstances do I want you to automatically execute this function. All right, let's consider some of the details of how triggers operate. First of all, when we're defining the function that's going to be invoked as a trigger, it actually needs to be declared slightly differently than what we've been seeing so far for a stored procedure or stored function. Two constraints have to be met. The first is that the function doesn't take any arguments. So we've seen in the past how we can define functions that take arbitrary arguments so we can pass into them when we use them, say, in a select statement. In the case of a trigger, because this is going to be automatically executed on behalf of an underlying query that we're issuing from our application, for example, the trigger mechanism doesn't know in advance anything about how to pass parameters to that. Now, that's not to say that we won't have access to the information that's being, say, inserted into the database. We'll see how that works in a second. But we don't pass any parameters to the function ourselves. And the second thing is that the function has to return a trigger, which is obviously just kind of a syntactic convenience to say, hey, this is going to be something that we can invoke as a trigger. There isn't really a trigger thing that you can access further in your code. Okay, so that's how we define the function. It's all of the same stuff that we saw before, dollar quoting, the begin-end block structure, all the ifs and conditionals and all that kind of stuff. Anything we've talked about with regard to a stored procedure can be used in one of these trigger functions, subject to these constraints. Then what we have to do once we've created the function is tell the database under what circumstances do we want to have that function be executed. And that's what the create trigger statement does. So we create a trigger, we give it a name because we can alter it or drop it in the future. So it's handy to have some way to refer to it. As I said before, you can either trigger the function before the operation, before the insert or update or delete, or after that operation. And so you can choose one of those two options, and then you have to tell the trigger itself under what events do you want this thing to be triggered. And we can see down here that that will be either an insert, a delete, an update, or a truncate. And as you can see here, because there's this OR clause that's available inside of that list of events, you could ask for the database to trigger the same underlying stored procedure under multiple of those situations. So if you have something that is going to do some validation in the case of either an insert or an update, for example, you could say create trigger, the name of the trigger, before insert or update. Triggers are going to apply a function to a specific table, so we have to give it a table name with the on clause here. And then there's kind of two different ways that we can invoke the underlying function that are determined by this next portion of the create trigger statement. We can trigger the behavior, the function, the underlying function, either on each of the rows that's involved in the underlying statement, or just one time. So if we say for each row in our trigger declaration, that's basically going to say for every row that's affected by the underlying database operation, run the function, run the stored procedure. So for example, if we try to, the example I've given here is to do a deletion. You'll know that you remember that when we do a delete, we want to give a where clause that specifies which rows are to be deleted. And any row that satisfies that where condition will be removed from the table. So that might select 0 rows, it might select all the rows, or if we leave off the where statement, it'll select all the rows, or it might choose some number of rows in between. When we say for each row, what we're saying is run the stored procedure on each of those rows. So hand the row to the stored procedure, execute the stored procedure, and then do what it tells you at the end. So if we were deleting 100 rows from some table, that would fire the stored procedure 100 times. The other possibility is we could say for each statement. In that case, we're just going to trigger the stored procedure one time. So if we call a delete function, or we invoke the delete function from SQL, and it turns out that there were 100 rows deleted, the stored procedure would only execute once for the overall delete, as opposed to 100 times for each of the rows that were being deleted. And then the final portion of the create trigger statement is to say what procedure we want to execute. So execute procedure and then the name of the trigger function. So back here, right, that would be the name that we supplied here in a declaration that took no parameters and returned a trigger. Now let's look at a little more extended example here of how we might actually put this into practice. So we're going to look at a database that stores employees, and I've got this super simple table for tracking employees. I'm giving them an ID value that's going to be an auto-incrementing integer, and then I'm just tracking the first name and the last name of each employee. And one of the things that a database system will often do is keep track of what's called an audit trail, or a sequence of the operations that were applied to a particularly important part of the database, so that you can kind of go back and see over time how those tables changed. In the case of this employee table, we only can store a single first name and a single last name. And if tomorrow somebody comes in and makes a change to that first name and that last name, we'd really be none the wiser by doing a query against the database or the employee table that the value had changed at some point, unless we went back and tried to look in some sort of obscure log file or somewhere like that. But the database itself, again, because we want to have the cells within the tables be scalar values, they can only hold one scalar value at a time. That's fine in many cases, but in others we might want to be able to keep track of changes over time. And that's the notion of an audit, or keeping an audit of the changes. So we might define another table here that I've referred to simply as an audit table. And what I want to do in this audit table, and this is just a completely synthetic example, I want to keep track of changes that were made to employees' last names. So maybe an employee gets married and they choose to change their name as part of that process. And in order to keep our records of employees over time, we'll keep track of the fact that somebody changed their name at a particular point in time. So the audit table here, and that's not a specifically SQL kind of a thing. That's just a generic term to keep track of this audit of information. So it's just an ordinary table that I've called employee audits, and then it gets an ID field, and then the employee that's referred to here. So when a particular employee changes his or her name, we're going to add an entry to the employee audits table that has employee ID being a foreign key referencing the ID column of the employee of interest. Then we're going to keep track of the employee's previous last name. So we want to keep track of the history, so we don't want to keep track of the new last name because that's what's going to go in the employees table. We want to keep track of the previous one. And then we also want to keep some historical information. So I'm going to have a timestamp, which is a date and a time, that's in a field called changed on. Okay, so what we want to do is anytime we update the last name of an employee, we want to create a new record in this employee audits table that indicates what the employee's last name used to be. Now, one way we could approach that would be to just try to ensure through some process or through some management edict that anytime anybody writes code that updates the employee table, they're sure to go in and make a change to the employee audit table in order to make sure that it stays up to date. As you might imagine, that kind of an edict or that kind of a constraint may well be followed, but it's easy to imagine a situation where a person who's new to this system goes in and makes a change to a last name in a new type of query, and they forget to update the audit table because they weren't aware of that. Much better from a data integrity point of view for us to embed that into the database itself by defining a stored procedure that knows how to create an entry in the employee audits table and to trigger that stored procedure automatically whenever somebody tries to update the last name column of the employee table. So just to kind of start us off here, I'm going to add some employees to my highly sophisticated employees table. So a couple of insert statements, and then we can see the contents of our employee table has both John Doe and Jane Smith in the database. All right, so now we're going to create the stored procedure and trigger it. Remember, that's a two-step process. We need to create the procedure first, and then we need to tell the database under what circumstances to execute that stored procedure. So the goal of the stored procedure itself is to create an entry in our employee audits table that reflects the change to a last name. But from the point of view of the stored procedure, all it needs to know how to do is create the employee audits table. It's going to be up to the trigger to say, hey, somebody made a change to last name, go ahead and run this stored procedure. So the stored procedure isn't checking to see if the last name changed, it's just responding to that in the case that somebody makes a modification to it. Okay, so here's our stored procedure. As we said before, we have to have a function that takes no arguments and returns a trigger, and then here's our dollar quoting syntax here, and I've put body as the tag here before and after just to show again that that's a possibility. And then the block that contains the stored procedure goes from the begin to the end. And inside of here, what we're going to do is we're going to inspect this row called new and the one called old. Now, where do those come from? Well, this is the way that the stored procedure mechanism kind of gets around the problem of not being able to know what parameters to pass to the function. We're not sending anything in here, but we know that this stored procedure, because it's a trigger, could be invoked at insert, update, or delete time. So in all three of those cases, there is going to be a row of interest, or potentially multiple rows of interest, if we're doing our procedure for each of the rows that are affected. And the way that that information gets made available to the stored procedure is in these two identifiers, new and old. So new refers to the row as it's going to be after the update, and old refers to the same row before the update. And the syntax here is just like we've seen previously when we're referring to, say, a record object in a stored procedure. We just say new dot and then the column name, old dot and then the column name. So if the new value of the last name is not the same as the old value of the last name, in other words, somebody changed the last name, we're going to do an insert statement. And it's going to be an insert into the employee audits table that's going to take the employee ID, whose name was changed, the old last name, because we want to keep track of what it was. The employee table itself will keep track of what it is, and then the date that it was changed on. And the values that we're going to put in there are the old ID. Now in this case, because we are unlikely to make a change to the employee's ID, I'm just choosing arbitrarily between the new value and the old value. Now, there would be pathological cases where that might not be valid, but in this case, it doesn't really matter whether we choose the new value or the old value on the assumption that the ID doesn't change for a particular employee. It is important, however, that we choose the old value for the last name column rather than the new one, right? Because the old one was the previous value of last name, and that's the one that we want to put into our audit table. And we are also making use of this built-in SQL function called now, which just gives us a timestamp for the current moment when this function gets executed. So the result of this insert statement is going to be to log the auditing information that we need to have about the employee whose last name was changed. And then that ends here. And then the last thing here, we're returning new. Now, it's kind of subtle here. It doesn't seem like it's doing very much, but what we're basically saying back to the update statement, that I want you to update this thing with this new row, this new row that was requested. Now, one of the things that is a little weird about this is that we're not making any change to that new row, so why do we bother returning it back to the database? Well, we could make a change to this. So, for example, if we wanted to make a change to one of the rows that was being added, or that was being updated in the database, as part of evaluating this stored procedure, we could do that. We could say new dot whatever field equals something, and that would result in that value being used in the database as part of the update process. So we can do that. We're not doing it here. Okay, again, the old state of the row in the table before the triggering event and after the triggering event, as we've just discussed. Okay, so now if we manage to invoke this stored procedure, this function, at the time of an update, that will cause the audit table to contain information about the previous value of last name for an employee and the time at which that was changed. Okay, so we've kind of got the mechanism in place, though what are we going to do? We also want to know when are we going to do it, and that's the job of the trigger itself. So we're going to do a second function call here to create a trigger. That trigger needs to get a name because we can refer to it later. We're going to do this before, right? We want to have some way of checking to see if we need to do something extra as we're adding this thing to the table, and we're going to do it before an update operation. Now, you might think, well, why not on an insert operation? Well, in that case, we're putting something new into the database, so it's not really possible for us to be making a change from some existing last name to a new last name. So we only need to do this on update, and we're going to do this on the employees table. Note that we're referring to the table where the underlying database operation will be performed. We're not saying, although the implementation of this trigger in this log last name changes function has more to do with updating the audit table, the trigger is going to be invoked when we make an update to the employee table, and that's why we list the employees table here. We want to do this for each row. Now in this case, that's not really that critical on the assumption that you're only going to probably update a single employee's name at a time. But it's not outside the realm of possibility that you might want to do, maybe you do a batch update every week, because this doesn't happen very much, and you want to change all of the employee names in one query or something like that. It would be possible to imagine a scenario where it would work that way, but why you'd want to change all of the Smiths to Wilsons or something like that is a little hard to imagine. At any rate, even though we're going to only do this probably on one row at a time, we'll invoke the stored procedure on that one row. And then, of course, here's the stored procedure, or the specification of the procedure that's going to be executed. Okay, so let's see how this might work in practice. Remember back here that we had John Doe and Jane Smith. Now what we're going to do is run an update against that employees table, and we're going to change the last name field to Brown, where the ID was equal to 2. So back here, the ID of 2 is Jane Smith, and what we see as a result of this change, if we go back and just select the contents of that employees table again, is that ID number 2 now has the last name of Brown. Again, this is what we mean by the underlying database operation. It's the thing that we're doing as part of our application logic to make a change to the state of the database. And as part of that process, the trigger says, hey, somebody's doing an update on the employees table. That means we should execute this stored procedure, the one that was specified here in the create trigger. And as you can see here now from the second part of this slide, that if we go look in the employee audits table, now we find that employee number 2 used to have a last name of Smith, right? This is the old value, and it was changed at the moment that this query was executed. So we get a timestamp there. This also is getting an identifier field automatically generated so that we have a primary key into that table. So the result showing up here came from executing the stored procedure, which was invoked because we'd set up a trigger for updates to the employee table. Okay, finally, we can also do some other things with the trigger. You can tell because we used create trigger that statement is part of the data definition language. So in addition to creates, we can also expect to see alters and drops. So for example, we can say rename the trigger to something new. By using the rename to, we can actually enable and disable the trigger as well. So maybe we want to have a trigger that has a stored procedure, but we only want to turn that trigger on at certain times. Rather than having to go back and completely redefine the trigger and then delete it entirely and then go back and redefine it, if you want to just be able to turn it on and off, you can use alter table to disable the trigger, and there's a corresponding enable trigger as well. And then finally, if we want to drop the trigger altogether, because we no longer need it for whatever purpose, we can use drop trigger. And notice we have to give both the name of the stored procedure and the table on which the trigger has been defined. This should suggest to you that it's possible to reuse a trigger function on multiple tables. So if I had, this is again, it's a contrived example, but if I had last names stored in various places in my database, probably a bad idea on the face of it, right? Because we got duplicated data. But if that was the case, and I wanted to make sure that I always logged changes to that, I could create the trigger for this function on multiple tables. And anytime the corresponding operation took place on that table, the trigger would fire. Because I could potentially attach a trigger function to multiple different tables, that's the reason I need to actually include this on clause in the drop trigger to say which one I want to drop that trigger from. And finally, here's some links to resources, both the Postgres manual itself and then the Postgres tutorial that we've been using. That's where the DVD rental example came from. They have a really nice, concise treatment of how to define and use triggers.